Hello, this is Helen Thomas and the CDFM study group. We will continue review of CDFM Module 4, Competency 2, Systems Engineering. So now we've established our ACAT category. We've established the decisions, the milestone decision authority for each of the ACATs. We've determined which ones are major defense acquisition programs, major automated information system, the MAZE, so 1AM automation MAZE. And then now we're going to look at engineering the system, what it incorporates. So systems engineering is on page 422. It gives you a definition in the middle of that first paragraph where it says it's applied to defense acquisition is the overarching process that a program goes through to transition from the stated capability to the actual operational system. So that whole process to go from paper to an actual equipment. This is exciting. So on page 423, systems engineering across the life cycle. Again, the responsibility goes through the program manager. And it mentions on the bottom of page 423, SEP, Systems Engineering Plan, is done by the program manager, and it is done beginning at milestone A. So you want to have the plan in place before you actually go into an acquisition program. So SEP begins at milestone A, and it is done. So at 7, let me read the other sentence. At milestone A, the SEP supports your technology strategy. So remember, milestone A is not the beginning of the acquisition program. It is where you do your analysis of the alternatives, your material solution analysis, you do your technology maturation, risk reduction. You're actually looking at reducing the risk. So milestone A is supporting technology strategy. At milestone B, it's supporting the acquisition strategy because remember, the acquisition program begins at milestone B. So it's either supporting technology development strategy or acquisition strategy. That's at the bottom of page 423. On page 424, it goes into configuration management. The PM or program manager should use a configuration management approach to establish control measures, strategies, and the technical baseline across the total system. So that's no different than what we've stated before, is the program manager have to process that whole capability requirement from the inception on that document, initial capabilities document, to having an actual product. And then once we have the product, how are we going to sustain the product for the life cycle? So if it's a life cycle of a product that have 5 years, that program manager has to come up with a configuration management. How are we going to maintain it? Just like I said, when you have a car and you got to do maintenance on the car because you want the car to continue to operate in the way in which you bought it. Page 425 looks at corrosion prevention. That's straightforward. Modular open system approach. Program managers must employ MOSA, modular open systems approach, to design for affordable change. So you want to have a system that you can interchange parts to it. So when they're developing the system, they think of a modular open system. They take that approach in developing them. The item unique identification is just a tail number. So let's say it's an aircraft. So the IUD or IUID, item unique identification, is serial number. For lack of a better word, it's the serial number for that item. Electromagnetic spectrum supportability, what type of system? How is it impacted by other systems or computer systems? So those are all the things you're looking at. So we're going to touch on some. Remember I said the program manager is the single most responsible, accountable individual in this process. However, they can't do it by themselves. So the only exception for that single point of accountability and responsibility is when a program support manager is assigned. That program support manager works is accountable for the decisions they make on behalf of the program manager. And they use integrated product teams during that process. So 426 talks about integrated product and process development. And let's see what I got highlighted here. Department of Defense. The concept of IPPD and integrated product teams shall be applied throughout the acquisition process to maximize practicability. Because the program manager cannot do all the work by himself, so he have different types of teams that work. Some are working level teams, they're lower. Then you have integrated product teams that integrate the different working level systems. And then you have an overall overarching integrated product team to pull all the parts together. On the bottom of page 426, it goes into the definition of IPPD. At the last two sentences, it says, the IPPD facilitates meeting costs and performances from product concept through production, including field support. That's your sustaining piece of it. One of the key tenets is multidisciplinary teamwork through these integrated product teams, IPTs. So your three types of teams are listed on page 427, which is your overarching integrated product team, integrating integrated product team, and working level integrated product team. All acquisition category ACAT 1 Delta and ACAT 1 AM programs will have an overarching, so they will have an OIPT to provide assistance oversight. The third paragraph, the program manager or designing in collaboration with OSD action officer from the office of the OIPT shall collaborate to form a co-lead and integrated product team. Then the third one says the program manager and the OSD action officer assisted by the IIPT should develop a working integrated product team. So the working level feeds into the integrated product level, and the integrating product level feeds into the overarching at the DoD level programs. The program manager is in charge of the program. The WIPTs are advisory bodies to the PM. Direct communication between the program office and all levels in the acquisition oversight and review process is expected, because again, they do all the analysis on the program. So they just wanted to introduce, and I think in chapter or competency 9, it goes into more detail with these integrating product teams. So overarching, all your DoD level programs have an overarching integrated product team. The program manager along with the users have an integrated product teams. And then as you get lower, you have the working level integrated product teams. So that was pretty straightforward there. All right, so I got nothing there. On page 4211, I go into technical management processes. So now we're looking at decision analysis. Decision analysis activities provide basis for evaluating and selecting alternatives. So this will help you to determine when you do the analysis of the alternatives, your courses of action, you have to have criteria. So your decision analysis process is the criteria that you establish in the beginning for the decision and the methods to be used in conducting the analysis. Technical planning, you got technical assessment. Page 4212 goes into requirements management. So it maintains traceability of all requirements from capability needs to document all changes throughout the process. So requirements management to record your changes. Configuration management we talked about before. So that's your audit trail for everything that you're doing throughout the configuration process. You want to document. So you complete an audit trail of all decisions and modifications made. Data management interface. So you still want to read through these, but some of these are straightforward. On page 4214, it goes into technical processes, stakeholder requirements. So the stakeholder or the warfighter tells you what is needed, that capability. So you do a requirements analysis, architectural design, implementation, where you develop is a process that actually yields the lowest level system elements in the hierarchy. So you implement at the lowest level. Verification confirms that the system meets the design. Did we build it right? You verify that what it is that is built, so that initial item that's built, did you do it correctly? Is it doing the things that we expected it to do in that initial capabilities document? Did you build it right? That's verify. So you got a few words. You got verify and you got validate. And then validate says, is it the right solution? Did we build it right? Verify that we build it right. Validate that it's the right solution. Verify, that is, did we build, verify that we build it right. Validate that it's the right solution. Verify that we build it right. Validate that it's the right solution. So again, you got to know the difference between those. So verify first that you build it correctly, and then validate that it actually is the solution to the capability problem. I think this one, yep. So let me highlight something here because I remember we talked about systems of systems. All right, so 4216 talks about systems of systems engineering. Systems of systems engineering deals with planning, analyzing, organizing, and integrating the capability of a mix of existing and a new system into a systems of systems. All right, what do I have here? So you have systems of systems and you have a family of systems. So we got to make sure we know the difference because I remember seeing this somewhere else, right? So let's see. Systems of systems should be treated and managed as systems in their own right and should therefore be subject to the same system process. A family of systems does not create capability beyond the additive sum of the individual capabilities of its member system. So what that sounds like is a system of systems mean they could stand alone. But if it's a part of a family of system, they need the individual parts to work together to be a functioning system, right? That's how I understood it. Systems of systems, meaning if I take that system out from the group, that system can stand alone. A family of systems mean that I need the mother, the father, the sister, the brother to put it all together for us to be a functioning family, right? So a family of systems does not create a capability outside of when everybody gets together. So I'm just putting it in my own words so that you can understand better. All right, let's see. Evolutionary acquisition, we already talked about that. It's either evolutionary or a single step, depending on the capability need and what's already out there in the inventory. So the summary, systems of systems, family of systems, technical management, evolutionary approach. All right, got it. So we're talking systems engineer. On page 4220, a recap again in that paragraph where it talks about the JROC recommendation is done on an initial capabilities document. So they analyze, determine the capability gap, and then the initial capabilities document tells what they need to develop to fix that capability gap or to fill the gap. When you do the analysis of the alternative, you get guidance from the DK, Director of Cost Assessment and Program Evaluation. Study guidance. Okay, that takes care of that. So page 4221 goes into the system lifecycle process of systems engineering. So the milestone decision authority shall approve the analysis of the alternative study guidance. And again, MDA's decision to begin material solution analysis does not mean that a new acquisition program has been initiated. At what point is a program initiated? It is initiated at milestone B. So once they get to milestone B and they look at all the material solution analysis data, they look at the technology maturation or risk reduction data, and then based on the acquisition program baseline, the card, all the different documents, then it's milestone B. The approval there is what initiates an acquisition program. So you look at all the terms. Do you recognize ICD, AOA? At the bottom of page 421, it says material solution analysis ends when the AOA has been completed. Analysis of the alternative. We do our analysis of our courses of action once we go through our decision analysis process. And we have a recommendation of which one of the courses of action we should move forward with. 4222, the purpose of technology. The technology phase is to reduce technology risk, determine the appropriate set of technologies to be used in that process. The top of page 4223 at milestone A, don't forget you do a SEP, Systems Engineering Plan, but it also says at milestone A, the MDA reviews the proposed material solution analysis and the draft technology development strategy. So remember, before you go to each phase, before you go through each milestone, there's a guidance, there's decision points that are being made. And all of this information is documented in an acquisition decision memorandum. How do you exit the technology development phase? Affordable increments of military useful capability, technology demonstrated in a relevant environment. You identify the risk, and then you identify the risk reduction methods. On page 4224 at milestone A, the DoD component shall submit a cost estimate proposed, identified by the AOA. So cost estimate, you start off with the acquisition program baseline from the program manager. So that's your program objective estimate. You do your capabilities estimate, and you do your independent cost estimate at the DoD level. So I'm just kind of recapping some of your cost estimating methods. All right, skip. Purpose of EMD on page 4228. The purpose of the engineering and manufacturing development phase is to develop a system as an incremental capability, complete full system integration, technology risk reduction. So all this data that we already have, we put it into action. The EMD, remember, it's material solution analysis, milestone A, technology risk. Then you come to milestone B. Once you get approval there, it initiates the acquisition program, and then you go into the EMD phase. The EMD on page 4229, second paragraph, has two major efforts: integrated system design and system capability and manufacturing process demonstration. So we want to develop a few of the items so now that we can actually put them in production to actually see how they operate on the battlefield. At the bottom of page 4231, remember I said the SEP in milestone A supports the technology development strategy. The SEP in milestone B supports the acquisition strategy. So now at the bottom of page 4231, it's repeating. For milestone B, the PM prepares and the MDA approves an acquisition strategy to guide the activity during the EMD. All of that is the same thing. So remember on number 5 on page 4231, I think in module 2, we talked about what happens in milestone B. They establish the LRIP, low rate initial production. That's the number of quantity, the smallest amount they plan to develop initially to put into tests, into field. That's your LRIP. So you do your LRIP also in milestone B. This is what you're trying to figure out as you study module 4 is what happens at milestone A, what happens at milestone B, and so forth. On page 4-34, then you go from EMD to production and deployment. The purpose of production and deployment is to achieve an operational capability. Bam. On 4-35, remember, milestone B, they determine the quantity, that LRIP. Now, when you come to production and deployment on 4-35, then they actually produce the LRIP in the production and deployment. So that's what they're talking about in that paragraph. The effort is intended to result in completion of manufacturing development in order to ensure the bottom line is that quantity, that number that they established in milestone B, now they're actually developing the item. 4-36 says that at production and deployment, once you do the LRIP, you do your testing, then they have another decision point, which is the full rate production. Before they actually go develop the rest of the item, the milestone decision authority needs to review the data from the LRIP. Why go spend billions of dollars when you need to analyze, does the thing do, does it verify that you build the right thing and validate that it is actually fulfilling the capability that we say we were missing. Four 239 goes into Title 42 U.S. Code, which covers disposal of these items. At the end of its useful life cycle, a system shall be demilitarized and disposed of in accordance to whatever the legal regulation says that you're supposed to dispose of. Either the item is destroyed or it's demilitarized. You take off all the military specific things and you sell it to other people in other countries. That's what demilitarized means. So let's see. In the summary on page 4-40, as you read through, you should recognize material solution analysis, the AOAs, and so forth. On the third paragraph, it goes again into the EMD, the purpose of the EMD phase, but it also talks about the human systems engineering. Remember, we said that's got to be introduced, milestone B. Design for productivity, protect the CPI by implementing appropriate measures. That's your critical information, performance information. The capabilities development document, acquisition strategy, SEP, and test and evaluation master plan guide this effort. So these are all the documents that we have created by the program manager in most cases. The SEP, the CDD is produced by the JROC. So remember, the JROC created the initial capabilities document, and then after technology, I think they developed the, initial capabilities, critical development document, and then the critical production document to tell you how to develop the item, capabilities development, and capabilities production document. So that CDD is capabilities development. All right, so everything else should be straightforward. So what are we trying to develop as we go through these capabilities is we want to have on page 4-43 an open system. Well, what does that mean? An open system is a system that employs modular design tenets, modular because we want to be able to use different parts, uses widely supported and consensus-based standards for its key interface, and is subject to validation and verification. Verify that we build the right thing, validate that it does what it says it's supposed to do to ensure the openness of its key interfaces. Okay, so you got the definition of the SEP. And instances, remember, acquisition is either evolutionary or single step. How can it be single step? Because on page 4245, sometimes we can use commercial off-the-shelf items. If in the commercial sector that we have a similar item of what we're trying to develop, single step may be tap into that pot, that commercial off-the-shelf item, and just add whatever specific military things that we need to add. Or maybe we don't. Maybe it's a drone that's on the commercial side already developed, and we just didn't have it in the military. So single step, we develop our own drones. So use of commercial items, significant opportunities for reduced development. That means we can get the item quicker into our inventory, into our capability to fill that gap, because we don't have to start from scratch. It's already commercially available. Page 4247, program managers should establish the reliability, availability, and the maintainability, the RAM. Reliable, available, maintainability. When in doubt, pick program manager, right? Should establish the RAM objective. Reliability requirement addresses mission, is reliable. Available requirements addresses the readiness of the system. Maintainability addresses the ease and efficiency of using that item. So make sure you look at those. Work without critical failure. So we want to make sure it's reliable. It can work without any critical failure. Available, it's readiness. And maintainability, ease of maintaining the item. We don't want something where, like sometimes you buy something in a store and only a specific, like if you buy a car from overseas somewhere, only their specific part can work on that car, versus if you have a modular system where it's supportable by other parts. So we already talked about supportability, human systems integration, our safety concerns, survivability on page 49, corrosion prevention, disposal, and demilitarization on page 51. So just kind of read through that information, because a lot of this becomes repetitive after a while. So you should be able to recognize a lot of these words. All right, still in systems engineering. I don't have a lot of highlights in these areas until page 4256. And actually, that's another recap again. SEP, the Systems Engineering Plan, is done at milestone A to support the technology development strategy. SEP is done at milestone B to support the acquisition strategy. See, I just repeated what was there and what is listed on page 4256. 4257 is important because modeling and simulation, those are your testing. We want to actually see how the item is performed on the battlefield. So at the top of page 58, 4258, modeling and simulation is done throughout the whole process, beginning at milestone A. It is an essential element of the total systems engineering process. Hit, tap, tap, whatever it is you need to do. Understand that modeling and simulation occurs throughout the entire total systems engineering process. That's what you need to know from there. And that's milestone, documentation. Okay, so you have another diagram again that goes into the tools, techniques, and resources for the acquisition process. All right, so that's the end of Module 4, Competency 2, Systems Engineering. All right, so to be sure to subscribe and let us know if you have any comments on any additional question. Maybe I need to clarify something on this video, and I'll be sure to get back with you on the YouTube with these answers. This is Helen Thomas in the CDFM study group. I'll see you guys again next time.